Hi students, today we'll discuss one more part, second part of our simple harmonic motion, that is simple pendulum now, right? So here SHM part 2, SHM part 2, right? Already I completed part 1, I already uploaded, please go through it, right? Those who did not watch now, please go through it now and come back to this part now. All this one now, right? In this one now we'll discuss simple pendulum now, one of the application of our simple harmonic motion now. Let us see. So here simple pendulum you might have seen like a pendulum clocks and all this one no. Pendulum. So pendulum means what? Here there is a one string is there no. This string. So it is now it is connected to one metallic bob now, right? This one metal bob. So this metal bob of mass m, this is having the string, other end it is suspended to the pendant now. Now here some terms are there. We are going to define what is the terms now. Here the terms here, what will be the length of the pendulum? Length. Length is what? The point of suspension to, therefore center of the bob. Therefore, like our center of gravity of the bob, the distance between the point of suspension to center of gravity of the bob, we will call it as like a length of the pendulum now. Clear? So now what I will do now, therefore we will take it to here now, like we will make it to oscillate here now, therefore it will make it to here. So here, now this is at mean position now, this is at mean position. Now we will take to here extreme, these are extreme positions now. When I am taking to the extreme position, what is going to happen now? So here from here to here the displacement is amplitude now. Therefore here now we are releasing onto this. So when you are releasing, so it will coming back. So what force it will be acting onto this one now to come back now? This having m. So therefore mg. So this is theta. So therefore here you can rewrite it as like a, this also theta. This is mg cos theta. Therefore this side it will be the mg sin theta. So mg sin theta is the restoring force. That means this is a force which is making the bob to move toward this side onto this. Clear? So now we will take it as restoring force. No? What is the restoring force here now? That is nothing but a mg sin theta. This is restoring force minus. It is coming back. We'll see that. Therefore force it will be equal to what? Mass into acceleration here now. So therefore acceleration is equals to minus g into, therefore it will be sin theta. So therefore theta is smaller. So therefore if theta is smaller, therefore this angular amplitude is smaller. So it is small. So therefore sin theta is nothing but a theta. Right? So this theta, what you can rewrite it now? This theta. So this is totally length of this one no. This it will be a certain amount of displacement here no. So we will take it as displacement. Sin theta is nothing but a, sin theta is nothing but a like theta, that is also nothing but a tan theta. Is theta. Acceleration is equals to minus g into theta. Therefore tan theta you can write down, this is your displacement and divided by the length of this one. So a is equals to minus g, so theta. Therefore what you can write it now? This is x by L. So therefore it will be in terms of x by L. Now a is equals to minus g by L into x. So we can compare this one with simple harmonic motion, minus omega square into x. So therefore omega square is equals to g by L, omega is equals to square root of g by L. Clear? So omega is equals to square root of g by L now. So now angular velocity, omega is equals to square root of g by L. So omega you can write down 2 pi by t r, therefore 2 pi into frequency. Therefore here time period it will be equal to 2 pi into square root of L by g. This is your time period now. Time period of a simple pendulum is nothing but a t is equals to 2 pi into square root of L by g. Clear? So now we will remember this derivation is only for for board examinations. No? So now for competitive examinations, time period, what is the time period now? Time period is equals to 2 pi into square root of L by g. So time period, what is the frequency? Frequency is nothing but 1 by time period, 1 by time period, that is nothing but 1 by 2 pi into square root of g by L. Clear? Now, so as time period of a simple pendulum, time period is directly proportional to the square root of length, and time period is inversely proportional to the square root of g. Therefore, as g value changes, so definitely the time period of a simple pendulum, it will be changes. Therefore, if g value increases, time period will be lesser, no? So if g value decreases, time period will be larger. Time period is larger means it is taking lot of time to complete one oscillation. That means frequency will be, so if time period increases, frequency will decrease. So length increases, no? Time period is also increases. If length decreases, time period also decreases. Time period is independent of amplitude. So that means amplitude should be provided very smaller onto this one, no? And also, so shape, size and mass of bob, provided that it should be slightly heavier, so it should not be too much lighter, no? Therefore, like a feather it is there, like a thermocol ball is there, no? Therefore, it will not come back because of due to the air resistance onto this. So it should be slightly heavier. It does not depend upon the shape, size of this one. Clear? We'll see some applications based on this simple pendulum, no? Let us see one simple example. Suppose there is a one pendulum is there. So this is pendulum is filled with water. This pendulum is filled with water, no? Right? Now slowly the pendulum, therefore this water which is there, no, it started leaking, no? Now therefore initially the time period was t. So how the time period will change? Most of the students, what they will think, no, it is an independent of length and mass and shape of the body, no? But here what will happen now, when the full of the water is there, no, therefore the center of gravity will be exactly in the midpoint onto this one. Therefore, suppose if the water, it is half of the water it is flown down. Suppose half of the water is flown down, so what will happen now? Therefore, the center of gravity, it will be shifted downward, no? So when the center of gravity is shifted downward, so the length of this one now slightly increases. So when the center of gravity shifted downward, length increases, no? Time period will initially increase. Then afterwards, what will happen now? Time period is increases, then afterwards frequency will be decreases. So finally what will happen now? Finally complete the water will be get empty onto this one, no? Again the center of gravity will be shifted to the back onto this center of this one, no? Again it will come back to the same length of this one, no? Then, so initially time period will increase, then again finally come back to the same time period now, right? So in this way you should be very careful in this type of questions on this one. You need to see the center of gravity changing or not also. Let us do some simple concept now. See here, the child is swinging on the swing, no, in the park. Suppose there is one child is there, is swinging, no. So what he is doing now? Therefore, he is swinging like this, right? So first initially sitting onto this, right? Sitting. So then what will happen now? While it is swinging, therefore he stood onto this. He stood. Therefore, what happened to the time period? When he is sitting, time period was t. So therefore, when he stands onto this one, when he stands, so what happened to the time period? When he is sitting onto this one, no? Therefore, so when you are sitting here means center of gravity will be very low onto this one, no? So that means it will be initially the center of gravity is here, right? Suppose here sitting onto this one, no? Sitting means what will happen now? Here, right? So he was sitting onto this one. Now what he is doing now? He is standing onto this. So he stands onto this one. When he stands, so therefore here the center of gravity, what will happen now? The center of gravity, it will be raised. So therefore what will happen now? Length will decrease. When length is decreasing, therefore what happen now? Time period will be decreases. So frequency will be increases. That means, so whenever it is sitting, no, therefore its time period is t. So suppose it stands, no, therefore length will be decreases, temperature, time period will be decreases, no, therefore he will do very quick oscillations. Clear? Now we will see one more applications onto this. So mostly this simple pendulum, no, simple pendulum will be used in pendulum clocks. Pendulum clock. pendulum clock. How the pendulum clock will be there? So here there is a one clock is there, no? In the olden days we used to use this pendulum clocks, no? This one clock. Here, therefore, there is a one pendulum was attached onto this. So this pendulum we will call it as like a seconds pendulum. So what you can call it now? Seconds pendulum. Seconds pendulum. Seconds pendulum means what? Time period it will be 2 seconds. So if it is time period is 2 seconds, no, that pendulum is said to be like a seconds pendulum, no. Therefore length it will be equal to 100 centimeter, that is nothing but a 1 meter. So how this pendulum clock it will work now? Therefore here 2 seconds. 2 seconds means completely it is taken as 2 seconds. That means from here to here to go to here and come back to here 1 second, no. Come back to here and go to here now 1 second now. Clear? So therefore here there will be clock will be there, no. Right? This is a clock, no. So here seconds pendulum is, seconds needle will be there. This seconds needle, what happened now? When it is going from here to here, therefore this is 2 motion, no, that is said to be 1 second. This is 4 second, no, therefore 1 second, no. So when the pendulum goes to here and come back, no, therefore the seconds needle will rotate, will be moved by 1 second. Then again it will go back and come to here, no, again. So therefore it will do the one more clock onto this. Clear? So therefore if time period increases, what will happen now? Time period increases, that means it's taking lot of time to come back onto this. Time period increases, that means frequency will be decreases. So frequency decreases means what? How the clock will run now? When it's taking lot of time to go down, no, clock will run slowly. Clock runs slowly. Clear? So that means frequency and clock running, it will be the exactly the same. Clear? So now we'll see these applications, no, keep in mind. So this clock running onto this one, no. So keep in mind, and we'll see, we'll attach one pendulum clock, no, in a lift and pendulum clock, no. So therefore I already taught the lift problems, no, as a one video is there. So please go through that video related to the lift problem. I'll tell you very quickly. If lift is going upward with an acceleration, so weight will increase. If it is lift is going downward with an acceleration, so weight will decrease. There is a one pendulum clock is there. This is one pendulum clock, no. So here there is a one pendulum is there. Now it's having time period is t and frequency is f now, right? So suppose this lift is going upward with an with a constant speed. Suppose it is going with a constant speed is constant, or going down with a constant speed. So acceleration is 0. Acceleration is 0 means time period it will be equal to 2 pi into square root of L by G. There is no change on this, right? Suppose if the lift is going upward with an acceleration A, therefore what will be the time period now? Time period it will be equal to 2 pi into square root of L by G plus A. Suppose if the lift is going downward with an acceleration A, so what will be the time period now? Time period is equals to 2 pi into square root of L by G minus A. So suppose if the lift is going upward with an acceleration, no, so time period what happened now? It is inversely proportional to the G. Time period is, what will happen now? G, this denominator is increased, so time period will be decreased. When time period decreased, frequency will increase. Frequency increases, clock how it will run now? Clock will run fastly. Clock runs fastly. Clear? Cut this. Right. Suppose if the lift is going downward with an acceleration, so therefore denominator will be decreased, so therefore time period will increase. So time period increase means it is taking a lot of time to go to here and to and fro motion. So therefore frequency what will happen now? Frequency will decrease. Frequency decreases means what will happen now? Clock will run slowly. Clear? So in this way, if the lift is going upward and downward with a constant speed, no, there is no change in the time period, there is no change in the frequency. This is a reason actually why we are not using nowadays pendulum clocks, no. This is only the reason why, because G value will change. Due to G value, change in the G value, so clock will be also changing, no. So G value is not constant, so therefore this time measurement by that pendulum clocks also is not constant onto this one, it will changes onto this. And also it is huge one, no? Therefore portability also it will be very, very difficult. Clear? So now let us see, suppose there is a one pendulum clock it is there, no? It is fixed onto the, there is a one pendulum is there, this one pendulum clock is there, it is fixed onto this one. So this trolley, therefore this is going with an acceleration A. What happened to this time period of this one now? When it is going on to this, therefore this pendulum it will be pushed toward this side. So it will be experiencing a pseudo force, no? This is A, and downward force is nothing but G. So resultant force is nothing but a root of A square plus G square. What will be the time period now? It will be 2 pi into square root of L by G effective, that is nothing but a root of G square plus A square. This is your time period onto this. If it is a trolley is going, it is accelerating toward this side. We will see one more application here now. Suppose upon to this trolley, there is a one pendulum is there, this pendulum. So this trolley is going with a constant speed, but is going in the form of like a, right. Suppose this is going with a constant speed in a circular path of the radius is r. Then what will be the time period now? So it is going, therefore when it is going in the circular path, no, it will be experiencing a centripetal acceleration onto this one. So what will be the acceleration here now? That is nothing but a v square by r. So what will be the time period now? You can rewrite it as time period. It will be equal to 2 pi into square root of L by, so just now we written, no? Therefore here it is root of a square plus root of g square plus a square, no? Right? So it is a root of, so g square plus a square is nothing but a v square by r whole square. This it will be your time period. So if a truck is there, no, in that one pendulum is there, it is connected, therefore and it is going in a circular path. Therefore this it will be your time period. And one more application here, no. Suppose here one pendulum clock is there, no, it is moving from the equator. Suppose this is the equator, no, therefore equator to the poles. This is your pole, equator to the pole. Clear? So you know that in our gravitation we already discussed, no. So radius at the equator and radius at the pole. Radius at the equator is larger than radius of the pole. What about the g value? G value is inversely proportional to the square of this distance, no, square of the radius. So therefore radius at the equator is larger, no, that means g value at the equator is smaller than the g value of the poles, no. Therefore if one pendulum clock is taken from equator to the pole, what happened to the time period? Time period will increase or decrease? We know when it is taken from equator to the pole, so therefore at the pole g value is larger. Time period, how it is related now? Time period is inversely proportional to the square root of the g value. Where g value is larger, their time period will be smaller now. Therefore when it is moving from equator to the pole, g value is increasing, time period will be decreasing, frequency will be increasing. Frequency is increasing, so clock will be also running faster now. Where the clock will run faster now? At the poles, the clock will run faster compared to at the equator. Clear? Now we'll see. Therefore this pendulum clock is there, no? This one pendulum, right? So this pendulum, so suppose this pendulum is there, no? Therefore it is having the mass m, it is having the charge q. So therefore some positive charge is given. Now here what we are going to do, we are going to provide some amount of electric field, or this pendulum is placed in between the two plates now. Therefore here this side is a positively charged plate, right? This is about negatively charged plate now. Now what will happen now when the pendulum taken to here? So it will be having one weight, that is nothing but mg. So because of due to this one now charges, there will be a electric field, it will be there. And this pendulum is also charged onto this one, no? This side positive charge, no? So it is going to experience a force, no? What is the force now? Therefore q times of our E. What will be the net force onto this one now? Net or G or A effective acceleration, how much now? Effective acceleration, it will be equal to this downward, it is G. So downward is G. Here this, due to this one, acceleration is how much now? Ma, it will be equal to Q into E, that is nothing but A is equals to QE by M. So therefore QE by M, this is your net effective acceleration. What will be the time period here now? Time period, it will be equal to 2 pi into square root of L by effective acceleration, that is nothing but G plus QE by M. So what will happen now? Denominator is increased, time period will be decreased now. Time period decreased means, so time period decreasing means frequency will be increasing now, right? Suppose you can see the polarity. Suppose if it is negative charge is there, if it is negative charge is there, what will happen now? It is going to experience upward force now at that time. So G minus QE by M. So therefore G minus QE by M. So therefore denominator is decreased. So therefore time period will increase. If this is negative charge, no, time period will be increased. So time period is increased means frequency will be decreased. So these type of questions also frequently asked in the JEE mains, no, right? So now we'll go for same type of question. One pendulum is there. This one pendulum of mass M, it is having charge Q. Suppose here what you are doing now, we are giving some amount of electric field here now. Electric field here, a uniform electric field. Like this is there means it is positive, negative. Suppose therefore it is comes to here, when it comes to here now, therefore what will happen now? Positive charge now, repulsion, it is going to experience a force. F is equals to QE, that implies acceleration is equals to QE by M. One more acceleration is there, that is nothing but a acceleration due to gravity. What will be the net acceleration here now? Therefore, it will be root of G square plus QE by M whole square. Clear? So what will be the time period now? Time period, it will be equal to 2 pi into square root of L by root of G square plus QE by M whole square. In this way, you can calculate the time period of a simple pendulum if an electric field is applied horizontally onto this. We will see one more concept related to the simple pendulum. No? Suppose there is a simple pendulum is there. This is one simple pendulum. So its time period is T. So when they are kept in the air, its having mass is M. So suppose the same simple pendulum, no, if we keep it inside the one liquid, right? So therefore, if I am going to keep this one inside the liquid now, so what is going to happen now? So because of due to the buoyancy force, no, therefore what will happen now? Its weight it will be reduced. So therefore here when it is kept here, no, therefore here what will happen now? This side downward force is mg and this side force is nothing but a upthrust. So what we can write it now? Apparent weight in the liquid, you can write down mg into 1 minus density of the liquid by density of the bob material onto this, right? So what will be the G value now? Therefore effective value of this one, no? Therefore the G into 1 minus density by density of the bob now. Therefore what you can write, time period is inversely proportional to the square root of the G. So here, so time period in the air, so time period in water or in liquid, no, time period in the liquid, so it is in the liquid by time period in the air, so it will be equal to square root of inversely proportional G value in the air, therefore this will be a effective onto this. Clear? Now, so what you can write it now? Therefore here it will be the G, so by G into density minus rho by density onto this one, no? This will get cancelled. So therefore density of the bob by density minus rho. So time period inside the liquid, so we can write down, so root density of the bob by density of the liquid minus density of the bob into time period in the air. So here what will happen now? Therefore time period it will be, because denominator is decreased, so this value is larger, time period in water or liquid, no, will be greater than time period in the air. In this way time period will increase. some questions now. See here. So here we are going, I will take one seconds pendulum, no? Seconds pendulum. Whenever there is a seconds pendulum, if you heard, no, time period it should be equal to 2 seconds. Length it should be equal to 1 meter. Okay. So if there is a seconds pendulum is there which is on the earth surface, no? If I take this seconds pendulum to the one planet whose mass is twice that of earth, no? Therefore one planet we are going to take it, no? So whose mass is twice that of earth, no? So whose radius is also twice that of our radius of the earth, no? Right? So if I take this pendulum to this planet, no, what should be the time period of that same pendulum clock, no? So simple pendulum, no, will calculate. So first of all you should calculate what will be the G value on this planet, no? So you know that in the gravitation lesson we studied G is equals to Gm by R square. So G value on the planet by G value on the earth, no, it will be equal to directly proportional mass. So mass of the planet by mass of the earth, no, inversely proportional. Radius of the earth by radius of the planet whole square. Clear? So here, no, therefore mass of the planet is how much, no? 2 times of our mass of the earth, no, by mass of the earth into, therefore radius of the earth is how much, no? Re. Radius of the planet is nothing but 2 times of Re whole square. Therefore what you will get it now? So 2 into 1 by 4, so that is nothing but 1 by 2. So G value on the planet, it will be equal to G value of the earth by 2. So time period, what is the formula? Time period is inversely proportional to the square root of G value. So time period on the planet by time period on the earth, no, it is inversely proportional, root of, so G value on the earth by G value on the planet. So what is the G value on the planet now? You can rewrite it as G value on the earth by, so G value on the earth into 2 get cancelled out, no? So time period on the planet is nothing but a root 2 times of your time period on the earth. What is the time period on the earth now? 2 seconds, no? Time period of a seconds pendulum on the planet, it will be nothing but a 2 root 2 seconds. Clear? So therefore G value is decreased, no? That's why time period is increased. So same type of question, no? One more question now we'll see. So same seconds pendulum, no, what we are going to do? So we are going to take this seconds pendulum. Seconds pendulum, right? Seconds pendulum means what? Time period is equals to 2 seconds. So we are going to take it to one planet. So this is one planet, no? So whose density of the planet, it will be equal to twice the density of the earth, no? Radius of the planet, it will be equal to twice the radius of the earth. It is in terms of density. So therefore you should know the G value in terms of density. So what is the G value, no? You already studied in your gravitation lesson. So we'll write it, no? Therefore it will be Gm by, so therefore it is Gm by, it is R square. So mass is equals to what we can write down? G by R square. Mass value you can write down 4 by 3 pi R cube into density. You understand, no? So this is R square, get cancelled out, no? So therefore 4 by 3 pi rho G R. This is the G value on a planet in terms of density. Clear? So therefore G value on the planet by G value on the earth, no, it is directly proportional to the density. Density on the planet by density on the earth, no, radius of the planet by radius of the earth, no. Clear? So what are they now? Density of the planet is nothing but twice that of this one, no? This is also twice that one, no? Therefore you will get it as, so 2 times, therefore it is also 2 times, no? G value on the planet, it is nothing but 2 times, therefore it will be 4 times of your G value. Therefore 4 times of the G value on the earth, no? So if you take the seconds pendulum to this planet, no? So how it will be? So you know that again time period is inversely proportional to the square root of G. So time period on the planet by time period on the earth, no? So G value on the earth by G value on the planet. So therefore here you can write down G value of the earth, so G value of the planet, so therefore it will be 1 by 4 times of this one. Therefore 1 by 2. So time period on the planet, it will be equal to time period on the earth by 2. So time period on the earth is nothing but 2 by 2. So therefore it will be 1 second. So here G value is increased. That's why time period it will be got decreased here now. Clear? Now we'll see, suppose here there is a this is one simple pendulum is there, no, therefore it is suspended with one string onto this string, metal string, no. So therefore at certain temperature, so some temperature theta 1, no, so it is having some time period, no. Now what happened now, if temperature is increased, therefore temperature what happened now, we are increasing the temperature. When temperature is increased, what is going to happen to the time period? When theta 1 is nothing but a time period is t, so when theta 2 time period is increased, temperature is increased, so what will happen now? So when temperature is increases, length of the string, no, so length of the metal string, no, therefore it is going to increase. So when temperature is increases because of due to the expansion, so therefore length it will be increases, directly proportional, length increases, time period also increases now. So therefore here time period it will be increase. Frequency what will happen now? Will be decreased. So clock, how it will run now? Clock will run slowly. Therefore in the summer season, therefore the pendulum clocks will run slowly. So in the winter season, therefore the pendulum clocks will run fastly onto this, right? So how to calculate the change in time period, no? So time period is directly proportional to the square root of length. So we can, this much maximum change will not there, no, only minor change it will be there. So therefore we can use an error method onto this one, no. So by using this we can write down change in time period by, so t it will be equal to, this is root, no, so L to the power 1 by 2, therefore 1 by 2 into change in length by length, original length. But we know it now, therefore here in the expansions lesson, no, therefore delta L by L is nothing but a alpha into delta theta. Clear? Alpha into delta theta. Therefore you can rewrite it as 1 by 2 alpha into delta theta. Therefore change in time period by fractional change in the time period, it will be equal to 1 by 2 alpha into delta theta. So we'll do some questions, no, related to this also, right? So how much amount of change in time period it will be there now? So you can write it as 1 by 2 alpha into delta theta into given time. That means in 1 day, 1 year, like that, no, this time you can mention it now. Clear? So in this way, therefore if temperature increases, so time period will be also increases. Clear? So these are the some of the applications of our simple pendulum, no.